Let's got the number 540, single element in sorted array. This is medium question. Let's get into it. You are given sorted array consisting of one integer, where every element appears exact twice, except for one element which appears exact once. Find the single elements that appears only one. Let's check with example 1. Okay, there is the 2, 1. So return 2. In this case, 10 is only 1, return 1. How are we gonna do? Okay, there is the similar question. That is easy. I remember that is easy difficulty, and this one is not at that time. The question provide unsorted, so the optimal solution is linear time. At that time, I used XOR. You know, we make the XOR. We do XOR operation while every element, and then only the single element value is left, because when we do XOR operation to number, if 2 is the same, the answer is 0. So every 2 is turn into 0. So finally, single element is left. But this one is we need to implement with a log n with constant space. How we gonna do? Okay, clue 1 is hint 1 is log n, and then hint 2 is sorted array with log n. Sorted array with log n. Okay, do you have any idea? Yes, that's right. We needed to use binary search. But there is some challenge, because if we do binary search, we need to value its target. But it did not provide any target, right? So second, if we did not get target, we needed to have one equation to decide which part, left part or right part. When divided by the middle, we needed to choose 1 for searching area, because binary search is divide and conquer approach. But if we find one if statement to choose which parties we need to choose, maybe we can use binary search. At that time, I have an idea to searching first but that must be mid value is even number of index. So my idea is this. Okay, let's nums is 1 1 2 2 3 3 4 5 5. At that time, index is 0 1 2 3 4 5 6 7 8, and then left is here, start here, right is start here. So mid is left, this is right, and then mid is 8 minus 0 is 4. So in this case, let's check. This is the even, right? So when the mid value is the even number, even index, and mid, and compare mid with the mid plus 1, and that this value is the same, that means the left side is there is no single number. Because if there are one single number, such as 5 here, and then this one must be different from here, because one item is shifted to right. It makes sense. So if this one is the same, there are no single number at that time, we need to search right side. But there is one single number here. Otherwise, there are 1 and 4 like that, because we need to ascending at that time. This one does not match it, so we need to search here. We will use this approach. Okay, first we make the left is 0, right is length nums minus 1, and then while left is right. Do we need to add equal? No, because we need to check the 2 value, not 1. So we need to left is that it cannot same as right one. So mid is left plus right minus left divided 2, because I don't want come up with integer overflow. And later, if mid is not even, this is odd, and then I will make this is even. And then if nums it is same as nums mid plus 1, at that time this one is the same as this one. That is this case, right? In this case, we need to increase left to where? Left plus 1? No. If left plus 1 is, it must be located to the not odd. So finally, even add plus 1, this is odd number, so it deduct 1 is it locate the same position. So it fall into the unlimited loop. So in this case, left must be plus 2, not 1, and else right is mid, and then finally return left. Okay, let's check the code. Now left is here, so mid is here, so this is same, yes, so mid plus 2, and then now mid is here. This one is does not same, right? So does not same right to mid. Oh, sorry. Now this one is 7, so it going here. And then this one is same. Yes, same. So right is first. And then now this one is not same. Left is 5. Okay. In this case, okay, let's check the code. Oh, there is no typo. Okay, let's sum it. Oops. I need to return not index value. Okay, which works, and then let's sum it. In this time complexity is log n because we use binary search, and then constant space because we do not use any data structure. Thank you.